Hello and welcome. This is Dr. Umar Farooq from Electronics and Communication Department, VNR, VJIET, Hyderabad. Uh, Today's lecture is about antenna arrays. So, in this lecture, we are going to discuss about first a brief recap of what we have discussed in the previous classes. Then I'll be discussing a brief introduction about antenna arrays. Then why we need antenna arrays, what is the purpose of using the antenna arrays, and then what are the factors that affect the overall radiation pattern of an antenna array. So we'll be seeing those factors that will affect or that will actually decide how a radiation pattern of an antenna array will look like. And then finally we'll see the classification or the various types of the antenna arrays. So let us start. Okay, so what we have discussed, because it is very important to connect it with the previous lectures, what we have discussed. So we need to be having the knowledge of what is an antenna, what are the different parameters of the antenna, like gain of the antenna, directivity of the antenna, beam width, bandwidth, and radiation pattern. How the radiation pattern of an individual antenna looks like. What is the gain of an antenna? For example, what is the gain of a half wave dipole? What is the gain of a monopole? What is the gain of a horn antenna? And then what are the different types of antennas, like like we can say horn antennas, dipole antennas, uh, reflectors, Yagi-Uda antennas. Okay. Okay, let us come to the main topic, that is the antenna arrays. What is the definition of an antenna array? Antenna array is actually a combination, or you can say a set of two or more antennas. The signal from antennas, they are combined, that is combined in order to achieve the improved performance. So when we are going to combine the two or more antennas, we do it for some purpose, and the purpose here is that the signal from the antennas is combined in order to achieve the improved performance in some parameters. Like we want an improved performance in gain, we want an improved performance in terms of the bandwidth, we want an improved performance in terms of the beam width, in terms of directivity. Okay, so you can say that antenna array is set of two or more antennas. What we do, if we have that single antenna like this, instead of single we take set of two or more than two antennas, and it will form an array. And the signal from this individual antenna, this antenna, this antenna, this antenna, it will combine. How it will combine, that we'll see in next few lectures. Okay, now arrays, they may be linear, like one-dimensional arrays, they may be planar, two-dimensional arrays, or they may be three-dimensional arrays. For example, here this is a linear array. So what we have done, we have taken a simple dipole antenna, four dipole antennas that are separated by some space, and we are giving some phase to each antenna element, and it forms a linear array. Similarly, if we are arranging the antennas like this two-dimensionally, for example, this is one antenna, this is second, this is third, this is fourth, five, six. Similarly, in this, along this x-axis and along y-axis, we are arranging. Like here, it is a rectangular array. Similarly, we can have a square array, we can have a circular array, we can have a different shapes of arrays. Okay, then finally we have a three-dimensional array. If we are arranging these antenna elements like this three-dimensionally, like here you can see those circular dots. These are the antennas. So it will form a three-dimensional rectangular array. Depending on the type of array, we are going to use linear array, we are going to use a planar array, we are going to use a three. So we will be getting uh, different performance. Okay, depending on the application, we can use. We have to see whether we can use this one, whether we can use this one, or whether we can use this one. Okay, so this is the basic, or you can say the introduction about an antenna array. That it is a set of two or more antennas. The signal from antennas are combined in order to achieve the improved performance. Now the question is, if we have a single antenna, why we are going for antenna arrays? Like here, you can see if we have this single antenna, what is the purpose that we are going to these much of the antennas? Similarly, if we have this antenna here, single antenna, why we are going to these much of the antennas? Number of reasons or advantages we get by going for antenna arrays. First one is that we know the gain of an individual antenna is not sufficient for most of the communication applications. For example, here we can say that gain of a dipole antenna, it is 2.2 dB. Okay, but there are some communication applications, or in most of the application, we need gain more than 2.2 dB. We may need 6 dB, we may need 10 dB, we may need 15 dB. So what we will do, one method of increasing the gain is that we will increase the dimension of the antenna, but that will not work every time, because it is very difficult to design an antenna with large dimensions and then fabricate it practically. Okay, that is the reason we are going for antenna arrays. Okay, so the answer to this question is, answer to the question that why we need antenna arrays is that gain of single antenna element, it is not sufficient. So under such cases, antenna arrays are used to improve the gain. Okay, and another answer to this question is that sometimes we need a point-to-point communication. For example, if this is the antenna here, like this, and this is the user. Okay, and the antenna usually it will radiate. If it is a omnidirectional antenna, it will radiate like this. Okay, but we need a point-to-point communication like this to this user. This is our antenna. Okay, suppose this is a half wave dipole antenna. Its radiation pattern will be ideally like this, but we want a point-to-point, or we want this beam directed towards the user only. Okay, so for that purpose we are using antenna arrays. So if you will use an antenna array like this, we can direct a beam. So instead of a radiation pattern like this, we can direct a beam to this user. Okay, so one answer to this question is why we need antenna arrays is that gain is improved. Another is that we can get a high directivity. Okay, so that the beam is directed towards the user. Okay, the other reasons for antenna arrays, that other reason for why we go for antenna arrays is the improvement in the bandwidth. The minor lobes, they are reduced. We can get a high signal to noise ratio. Since we are getting the high gain, we can get a high signal to noise ratio. Okay, also with the help of arrays, we can get the seriable beams. That is, we can, like here you can see, this time I am directing the beam towards this. I can direct the beam if there is another user here, like this. I can direct the beam towards this. If the user is here, I can direct the beam towards this. Okay, so with the help of antenna arrays I can steer the beam wherever I want. Okay, next is that what are the factors that will decide the radiation pattern of the antenna array. For example, this is our antenna array. Okay, this is antenna element 1, antenna element 2, antenna element 3 and antenna element 4. Which factors will decide the radiation pattern, like whether the radiation pattern will be like this in this direction, whether the radiation pattern will be in this direction, whether it will be in this direction or what direction. So what are the factors that will decide in which direction the beam will be? Okay, so the first factor is the shape of antenna array, that is whether this antenna array is linear or whether it is, we can say, planar, whether it is a three-dimensional array. Okay, whether the shape of the antenna array is linear, circular, rectangular, three-dimensional. Another factor is the size of the antenna array, that is how many elements I am using in the antenna array, whether the elements I am using are 3 elements, whether there are 4 elements, whether 5 elements, whether 7 elements. Okay, another is factor is the spacing between the antenna elements. If this is one antenna element, this is another antenna element, what is the spacing between these two? Okay, fourth factor is the excitation amplitude of the individual antenna elements, that is with which amplitude I am going to excite these antennas. And the phase of the individual antenna elements, like with which phase, it is the phase difference of the excitation that I am giving to these antenna elements, whether the phase is I am giving them excitation with different phases or with the same phases. And the last one is the radiation pattern of the individual antenna element. Okay, that will be also a deciding factor in the overall radiation pattern of the antenna array. Okay, so these are the some of the factors that will decide how this overall radiation pattern of an antenna array will be. The next is the classification. Here I am going to discuss this very briefly because in the next few lectures you have to go in it in detail. So the classification, the broadly we can divide the antenna arrays as one is broadside array, another is end fire array. Okay, and there are other types like collinear arrays, log periodic arrays, center fed arrays, end fed arrays, parasitic arrays, and so on. Okay, and what is a broadside array? Okay, if the radiation pattern of, suppose here this is an array, this is the antenna element 1, this is 2, this is 3, this is 4, this is 5. If the radiation pattern is perpendicular, that is the direction of the main beam is here like this. If it is perpendicular to the axis of the array, here this is the axis of array and this is the radiation pattern. Here you can see the radiation pattern is perpendicular to the axis of the array. So this is called as broadside array. Okay, and if the radiation pattern is, suppose here this is array, this is antenna element 1, 2, 3, 4, 5, 6. These are the antenna elements. If the radiation pattern or the main beam of the radiation pattern is along the axis, this is the axis of array and this is the main beam of the radiation pattern. If it is along the axis of the array, we say it is an end fire array. Okay, now how can we get with the same set? If this is the, here also we have 4-5 antenna elements, and in broadside antenna array we have 4-5. How we can get a radiation end fire array and how we can get a broadside array. That is how we can get a man beam in this direction or how we can get a man beam in this direction. This will, as I told you earlier in this slide, that the factors that will decide how this radiation pattern will look like, it will depend on these factors. So it will depend on the excitation amplitude, it will depend on excitation phase, it will depend on spacing and other these factors. Same way in the broad side array, we are getting this perpendicular to the axis of array with these features. That is, the elements are spaced equally and the spacing between the elements vary from lambda by 2 to lambda, while lambda is the wavelength of this antenna frequency. And another factor is all the arrays are fed in the same phase. Okay, so with these factors in a broadside array, if it is antenna element 1, it is 2, and it is antenna element 3, I am getting a radiation beam that is perpendicular to the axis of the array. Okay, and in case of an end fire array, these are the factors. Like here, again the elements are equally spaced, but the spacing varies from lambda by 4 to 3 lambda by 4, and the individual elements are excited with different phases. So with these factors, I am getting, if it is the antenna number 1, 2, 3 and 4 of the array, with these factors, like the spacing is like lambda by 4 to 3 lambda by 4, and I am feeding them with the different phase. I am feeding whatever the phase here, it will be different than this it will be. So with those factors, I am getting a beam that is lying along the axis of the array. Okay, so I hope you have understood these things in the today's topic, that is what is an antenna array. Okay, and why we need antenna arrays, and what are the factors that decide radiation pattern of an antenna array, and finally what are the different types of arrays. Okay, what we mean by antenna array is nothing but we are just combining or using a set of 2 or more antennas. Why we need antenna arrays? Just to get the improved performance, like we want more gain, we want more directivity, we want more beam width, bandwidth. What are the factors that decide the radiation pattern of the antenna? The phase, individual phase, the shape of the antenna array, the spacing between the antenna elements. So these are some of the factors. And then finally, what are the types? Broadside array, end fire array, collinear array, and feed array, center feed array. Okay, this is all about today's topic. Thank you.